Okay, so this is the workbook for lesson 17, or for workbook 17. Make sure you watch the other video to understand the concepts here. So what this first problem is talking about is we have the opposite sides of this parallelogram. By definition, in this lesson, they are the same. So the question, and don't be fooled by this and don't be too hasty, it says determine the value of y. And then I stopped there. I tried it the first time and I got it wrong because I just said, oh, look, determine the value of y. And then I stopped. But what we're supposed to do with it is determine the value of y to figure out the length of AB. So because this is geometry, there's also algebra stuff in there because we assume that you know some algebra. So we want 4y to equal y plus 18. So then you'd have to just solve an equation with that. Let me see if I can do that here. So you make 4y equal y plus 18, and you're going to take away y from both sides. So because we're trying to balance things, we want to isolate everything on one side, get all the y's on one side, all the other numbers on the other side to solve it. So take away y from both sides. You can because it remains equal. So if we add 4 y's, we took 1 y away. How many y's would we have? So if you have 3 y's that equal 18, how much is each y worth? So you might be able to see that you can divide both sides by 3. And so 18 divided by 3 is 6. And if you get beat with the stupid stick like I did, then you're like, oh, the answer's 6. And so you typed it in. But don't do that. Don't do it. Don't listen to that voice. You want to figure out what AB is. So AB is this side right here, which we can see that it's 4 times those. And so our answer is going to be 24. If you can't remember that, I'm sorry. Let's see. So then you just type in 24. Okay, next one. This one's the reason why I've done this. Okay, so we always start with given. Oh, it's on erase still. Okay, so we always start with given. Oh, there it is. My old cat, she's making some weird noises if you hear that. Then we said this statement right here is it's saying that AB and CD are the same, and AD and BC are the same. And that's just what a parallelogram means. But we can say that as opposite sides of a parallelogram are congruent. And then 9 and 11, those are opposite of each other. They make V's, so it's vertical angles. And then AB is parallel to BC. Well, that goes back to it being a parallelogram. So definition of parallelogram. There we are. Okay. Okay, so now we have sides, an angle, and a side. So this would be, oh wait, so then 2 and 5, those are alternate interior angles first. There's an angle. So angle, side, angle, right? Angle, side, angle. Let's just double check. So we said that, oh, we're talking about that. Dun, 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 dun. Angle, angle, side must be angle, angle, side. Let's see. I'm pausing. Okay, so coming back here, we said 9 and 10 are the same. We said 2 and 5 are the same. So that's an angle, and then the beginning statement, this one right here, said that those sides are the same. So those triangles are congruent by angle, angle, side. And then that means that AE and CE, like all those things. So like AE is congruent to CE and DE is congruent to BE. So that was just because the corresponding parts of congruent triangles are congruent. So that, I mean, what we're trying to prove is that, right? We're trying to prove that they're congruent. And if they're congruent, that means that E is a midpoint. That's just a definition of midpoint. And we couldn't say this, even though that's technically what we just learned in this lesson. But we can't say that until we prove it. So we had to prove it with triangles. Because triangles are really helpful. We know that the triangles are congruent, so the parts of them are congruent. So that means that E has to be the midpoint, and therefore they bisect each other, and that's definition of bisect, which is what we wanted to prove in the first place. They bisect each other. Okay, that is 17.1. And then 17.2. Oh, there's my little picture. So now we have angles and parallelograms, but was also the lesson talking about those angles being the opposite angles are congruent, and the consecutive, is that what they call them? Adjacent, the ones next to each other, add up to 180. They're supplementary. Okay. So what is the value of x? So those two have to equal each other. So if x plus 30 is equal, plus x equals 180. No, they don't equal each other. They add up to 180. But if I had x plus 30, that would be 2x plus 30. So 2x plus 30 equals 180. So then we want to solve for x. So we'd minus 30 from both sides. So then 2x's would equal 150, right? Because those 30s cancel out. And then 180 minus 30 is 150. And then divide both sides by 2. And I'm not going to even show that. If you think 150 divided by 2, if you have $1.50 and you split it into 2, then each person would get 75. Oops, it's supposed to be a 7. And there's a 5. Okay. So coming back to here, it would be 75. Pausing it. Whew, good thing it's not approved. Okay, so we have that AB is parallel to CD and AD is parallel to BC, and AC is a diagonal from both parallel lines. Paula says that being angle B is equal to angle D, congruent to angle D, proves that. She uses the alternate interior angles theorem, and she finds that AC is congruent to itself by the reflexive property. So alternate interior angles. So she said 1 and 2 are the same, and 3 and 4 are the same, and they have that. So then she used that by angle side angle. Good. She showed that those triangles are the same, and since corresponding parts are congruent, triangles are congruent, B would have to be congruent to D. Good. Which pairs of angles could Paula have concluded are congruent using the alternate interior angles theorem? Oh, I just talked about that. So it'd be 1 and 2 goes with 3 and 4. 1 and 2 goes with 3 and 4. There we go. Oh, well, it needs to be on regular click. Maybe. Okay, 1 goes with 2 and 3 goes with 4. Good. All right, so that was workbook 17. And we can do the checkpoint now, just to make sure it's all complete. Again, I'm only doing all these things just to help you get caught up. If you are watching these, you are behind the regular suggested schedule, and that doesn't feel fun at all. So, oh, look at this. Here's a video, a recap to help prepare for this checkpoint. So that's the one that I created. So then the checkpoints, I haven't been doing those for you. When I created that was a couple weeks ago. So now I'm going to assume that you're desperate and that you need help. So I will help you with this. So looking at this one, we know that those two things have to be the same. So this is just a lot of algebra. So let me write that down. This is writing with my finger on a mouse pad. Okay, so 9x plus 8 has to equal 8x plus 2. We want to get all the x's on the one side, all the other numbers on the other side. So we can, this is my plan. I'm going to minus 8x from both sides. And then I want this number on the other side, so I'm going to minus 8 from both sides also. So like this. So then the 8x's would cancel, the 8's would cancel, and 9x minus 8x is 1x. So we just put x. Then 2 minus 8 is negative 6. So the answer is negative 6, which I can do here. Do not include the degree symbol. So we go negative 6. And then question 2, which is harder than the other things. And therefore, I don't think very nice. Okay. So this one says that CE and BE have those lengths respectively. We know they're supposed to equal the same thing. So we want to find again the value of x. This is nice. It's not telling us to find the whole length. So we set them equal to each other. And we want to get the x's. I'm going to get the x's on the side with the 2x because then all the x's are all together and then I don't have to have weird moving a lot of things. So I'm going to add x to both sides like so. So then 15 would equal 3x. And if we divide both, divide both sides by 3, I can see that x would be equal to 5. Okay, next one. And lucky us, it's a proof, which is the good news is it's only 5 steps. And the first one is always going to be given, so that's really only 4 steps. So it says that it's a parallelogram right here. So then if it says anything about them being parallel, that's just definition of parallelogram. And then they're saying prove angle A is supplementary to angle D. So let's see, we want A and D to be supplementary. So they're saying that AD is a diagonal of AB and CD. So this is why this is really important. That's false because AD is right here. And so it cannot be a diagonal. That's false. So we're going to pretend like they wrote it correctly. And I'm going to just pause this and take a picture of it so I can send it to them. Okay, that's been noted. So now this is the thing is AD is not a diagonal. A diagonal would be AC or DB or BD, whatever. But that's not what it is according to this thing. But we can still probably guess what they're trying to talk about. They use the word diagonal here. I'm going to use definition of diagonal. Sounds very logical. And then angle A and angle D are same side interior angles. That is, if that's a diagonal, then that would be same side interior angles theorem. Then A is supplementary to D. Actually, I'm going to change my mind. The theorem is usually what states that they're congruent. So same side interior angles theorem is going to go right here. And then this will just be the definition of same side interior. So that's a really popular thing to do in here. The definition and then the theorem. And yep, there we go. All right, next question is this one. So it's not a however many step thing. It's just saying some mistake was made. So which answer correctly fills the blank for statement 3? So something about alternate interior angles. So let's just look and see. Let's see. They said that those are alternate interior angles by definition. And so then we want to say that the measures of those are to say that those are congruent. So we want to say WXZ and YZX. And then the ones below WZX and YXZ. So those, looking at those things, those are all the same. So it's got to be that one. Okay. Uh-oh. Something happened on that first one. What does it say? What is the value of X? Well, it is -6. Let's just see what it said on the answer key. Which to me means that unless you went back and just kind of re-guessed and maybe guessed the wrong thing. So that's got to be a 25% difference on all of your grades. I will see what I can do to change that.